Hi, this is Chris Brown, and today we're going to build this drag and drop puzzle game for kids that was designed by one of my digital media students at Kendall. As you can see, we have this lovely design of a fire truck puzzle with some pieces that need to be dragged into the correct place. This was designed at 1024 by 768, which is the standard iPad resolution. So the code that we're going to use will work both for the web with mouse commands and on iPads for touch commands. The mouse commands carry through, so it works quite nicely on the iPad once published. Here is a quick view of the finished code. I'm going to help you step through right now, which can be found in its entirety in the blog post below. So let's go ahead and get started. First thing, before we get into any code, is we need to make sure that the objects we want to communicate with code have instance names. What this means is we have our puzzle pieces on stage here, and each one is a movie clip symbol. So this one's a movie clip symbol named window. But it's very important to give the window an instance name, or what I like to refer to as a stage name. You need to give the individual instance of the symbol that's on the stage a name. In this case, we're copying the name of the instance, or of the symbol, since there's only one instance of each one. But this one is named window. We have ladder, water pipe, tires, tire, and door. And these are the objects that, again, it's extremely important to make sure that these have a stage name or an instance name before we start coding, so when we try to talk to them with the code knows what the heck we're trying to communicate with. So we have those all set. We have our 6 objects, so now let's go ahead and start programming this. I'm going to put all this on frame 1 of the actions layer. Open up this actions frame. We already have a stop command there. That's just holding the timeline on frame 1, which is great. I'm actually going to pin this script in case I inevitably click away from that frame. I'll just leave this script up here. It's all going to be in the same place. Now, the first thing we want to do, put a little comment here, is we want to set up the buttons for the puzzle pieces. All right, so the first step, let's start with our window piece. And since these are all movie clips, we need to first set up their button mode. So we'll say window dot button mode equals true. And what this does for us when we test the movie, command return, you can see that now when we roll over the window command, it gives us the little Mickey Mouse hand cursor to let us know it's a button object to click on. We're viewing it on the web on a computer. All right, so now that we have that, now let's go ahead and add our event to our button. So window.add event listener, and the type we want to add is a mouse event mouse down. Again, this will also work as a touch event when you touch your finger to the screen on an iPad. And the function that we want to happen when you press the mouse down is we want it to start dragging, which we will define later. So there we go. We have our event listener added. Let's see. Now we can set when we have the mouse up. So let's do a window. In fact, we can just go ahead and copy this line. Save a little time here. Paste one down below, and this time when the mouse is up, or you release your finger from the screen, we will want to stop dragging. So we have our first window button all set up. Set the button mode to true, set both of the mouse down or touch down and up events, and now let's go ahead and define these functions. So we'll create a new function named StartDraging. It takes a mouse event, alright, sometimes it likes to try and autofill and add this import statement, which typically if you're not using a separate ActionScript class file you don't need. In this case we don't need that, so we'll just go ahead and get rid of it. Alright, and we'll also copy this and define our function for stop dragging. All right, so now the first thing we'll do, I typically like to just add a trace statement in the function before I go any further, just to make sure that the button is set up correctly. We didn't make a mistake in our button. I'm going to test the movie, and now when I attempt to click and drag the window, get a little start dragging, and then when I release my mouse, oh, looks like it has to be over the window. Start dragging, I release it over, it says stop dragging. We'll actually drag the object and we'll be able to get our mouse outside of it, so that won't be an issue. Alright, so we'll go back to the actions. That works. Remove our trace statements. And now, because we're actually going to set these same functions to each of our 6 different puzzle pieces, we don't just want to say window.startDrag. We want to have this be dynamic, so multiple pieces can use the same function. And in that case, we're going to use E for the mouse event, current target, which will tell us whichever movie clip fired this event. And we simply want to say start drag. And concurrently, we want to set this to stop drag. Let's go ahead and try that out, see if we can drag our window now. And look at that. We can suddenly drag our piece around the screen. Very nice. Okay, so the next step is to copy this button code, and let's actually make 6 copies of it and add our other pieces. So our next piece, let's see. So we have the window, we have the ladder, water pipe, tires, tire, and door. So let's go ahead and use, instead of typing all of that, let's hit Command F for find and replace while we're in the code window. And with my cursor sitting here at this second block of code so I don't affect the first button, let's type in, we'll find window, and we'll replace it with ladder. And we'll just do it one at a time. Oops, I want to replace them, not just find them. Do that again. Command F, window, ladder, and we will replace one at a time. And I want to start here. Okay. Apparently I'll just hit find next until I get through the first ones. Now, in the second set, I can start hitting replace, and it will replace those 3 with ladder. And then we'll change this to water pipe. Replace those 3. And we had tires. Place those 3. And then tire singular. And again, when you hit find next, which is how I cycled through the first couple, I did not want to change. That just shows you what you're trying to find and goes to the next one. Hitting replace will actually change it. And the final one, I believe, was door. Replace, replace, replace. Close that. Command return to test our movie. And now we can drag all of our pieces all over the place. Very nice. So now would be a good time, Command S, to save the project. It's good practice. Okay, so the dragging setup, that was pretty easy. Take a quick look at the final code here. Yeah, okay. Our next step is now we are going to need to figure out exactly where these pieces need to be. We need to figure out where is the correct place for them to be dropped, so we can actually play the game. But at the same time, the behavior that we actually want is when we drag something, if I try and drag a piece into the wrong spot and let go, I don't want it to just stay where I dragged it. I want it to actually snap back to where it started. So we really need to record two different positions for each of these different objects. We need to record where it starts out, so it can snap back to that position if it's dropped in the wrong place. And we also need to record where it is supposed to end up, so we know what's the correct place to drop it. So we're going to create a few variables to do that. I believe those were start x and y and end x and y. Yes, so we'll start with the window here. And we want to go back in Flash, and we just want to create a variable for the starting x and y position of each of these objects. All right, so let's start with the window. The window starts at 146x by 217y. So we're going to go back into our code, and we need to record all of this. Let's see. We'll change our comment to say set up the variables and buttons for the puzzle pieces. So now that we have the buttons set up, we'll go over our window here. Now we're going to set up a new variable named window start x, which is going to be, let's see, probably should just use an integer. Let's see, did I use integers or numbers? Yeah, I went ahead and used integers. Good. And that equals, what was it again? 146, and the y is 217. Into our code, this is 146. And then we'll copy this line, set up our window start y to equal 217. So now we have the coordinates of where this object originates. Next we need to copy these two lines. Oops. And this time we're going to find the window end x and window end y. And this is going to be the correct position where the window ends up. So we'll just kind of drag it over here, maybe use the arrow keys to try and tighten it exactly where it looks like it should be. See, in this case I have 780 by 431. I'm going to check my original code and just see if that's 780 by 432. That's what I had in there. So let's see. Yeah, that looks about right. Alright, so I'm just going to hit Command Z and undo a couple of times until this window snaps back to where it started. Okay, so 780 by 432, I believe. Okay, so instead of going through that for each item, you can see what we're doing here is I just have to create the same variables. So next we'll set up a ladder start x, ladder start y, ladder end x, ladder end y, and so on and so forth for each of the 6 pieces. And for each one, we'll record its start position and then its correct dragged end position to fit the puzzle correctly. So I'm just going to go ahead and copy that. Let's see, I already have that written. I'll just copy the rest of these that are already in here and paste them in to save us a little bit of time. You should be able to get the gist. Okay, see, code adds up quickly, but it's not so complicated when you're building it piece by piece. So now we have the first section completely done. We set up the variables and buttons for the puzzle pieces. Each of our 6 puzzle pieces now has 7 lines of code, and it simply sets up the button for each one and also sets up the proper starting and ending coordinates for each one, which is the information that we really need to play our game. So again, great time to save. And I'm just going to test the movie again just to make sure I don't get any compile errors. Everything's right. Nothing works differently than it did last time. We can still just drag the pieces around, but now we have these variables that we're going to work with next that gives us our ability to actually play the game. We don't need to change anything about the StartDraging function. That's all that clicking the mouse down or touching your finger down is going to do, is just start dragging the piece. Where the gameplay or the game logic actually comes into place is in the stop dragging function. Because yes, when we release the mouse or we release our finger, the iPad, we do want to stop dragging the piece, and that's what happens now. But now we want to add some other functionality. Now we want to start checking for which piece are we actually dragging, and is it in its correct place, and do what's necessary depending on all these elements. So the very first step, since each of our 6 are using the same function, is to determine which piece we're actually using, so we can determine which set of coordinates that we need to check against. So we're going to use a switch statement for that. Instead of a series of 6 if-else statements, a switch statement will just make the code a little bit cleaner for us. So I'm going to switch for the value of the current target again. And if in the case that the current target is window, we will do something and then break. I always like to set up my case statement structure completely. I can copy this window case. We can make 6 versions of that. So we have a case for window, ladder, water pipe, tires, tire, and finally door. Now again, at this point, just to make sure that the switch statement is set up correctly, I like to go ahead and start with a trace command, and we'll put that in each of these cases. So that we can test, once we finish putting this in, when we stop dragging the puzzle piece, it should trace in the output window for us which piece we're dragging, which is the first step in doing our next puzzle game logic. And finally, door. So hit save again, can't do that too often. Command return to test the movie. Don't have any errors, but now if I drag the ladder around and release it, it tells me ladder. Window, water pipe, tires, tire, and door. Great. So that part works properly. So now we officially know which piece we're dragging. So now we can get rid of these trace statements. I'm just going to keep hitting undo. No, they were very useful in case something did not go correctly. Well, it's better to know earlier on and kind of trace things out periodically rather than get too far ahead of yourself before you know what the problem is. So now, what do we want to do? When we release one of these objects, we basically want to check to see if it's in the correct place. And if it's in the correct place, we just want to leave it. If it's not in the correct place, then we want it to jump back to the initial position that it started in. So we can do this with a window with a simple if statement. If window, since we know this is the piece that we're working with, if window.x is equal to window end x, which is the variable that we set up that tells us which x position it's supposed to be in, and window.y, because it has to be snapped in the correct spot on both the x and y axis, is equal to window and y. If this is the case, then we'll actually put a little trace command that says correct for now. Else, if this is not the case, then we'll want to set the piece back to its original position. So if we drop it anywhere except for if its new x matches exactly where the n should be and its new y matches exactly where the y should be, anything else than that and it's going to snap back to its original position. So we'll want to set window.x equals window startx, which is why we defined that variable. Just copy this, do the same for the y, and set the y back to the start y. So this will be a good test now. Test our window. So here's our window. If I drag it into the wrong position and let go, it should snap back to the beginning, and it does. So anywhere now I let go that's not over the window, snaps back to the beginning. Now let's see if I can get this right in the right pixel place. So if I snap this over the window and I let go, there we go. And jumped back after I clicked again, but if we let go, oh, this actually points out the next part of our game. It's honestly quite difficult to snap the object in exactly the correct pixel. Exactly the correct place. Let's see if I can even get it. Ah, there it goes. So I finally snapped it into the exact correct X and Y positions, and I got the correct output message here. So as you can see, that was a little troubling, so we're going to have to go ahead and fix that. Now, instead of adding the same code to each of the other puzzle pieces and having the exact same issue of it being a little too difficult to snap exactly pixel by pixel into the spot, let's go ahead and make the changes and get this window one working properly, and then we'll end up just copying the final correct method into the other pieces, and that should save us some time than kind of having to do everything 6 times. It's always smart to try and work with one piece or one button and get things working properly, and then kind of move on to add that behavior to the others. So what we need to do is we need to create another variable and create an offset. What this means is we'll create a variable that we'll actually be able to change that will determine how much error the user can have, meaning how many pixels away from the actual spot it will still be considered an okay fit. So what I mean by that is when we test it out here, when I drag the window, okay, yeah, this is a little far off. This is probably 10, 15 pixels or so, and that should still snap away. But if it's close enough, if it's like right here and it might not be the exact pixels, it's still snapping away, that should still stick. So we want a variable that we could actually do some game testing and decide, you know, what is a good reasonable pixel offset that isn't too sloppy but still isn't too precise, so it's easy enough for kids specifically to do. So the first step is to go ahead and set our variable. We'll put this back at the very top above all of our piece variables and above all of our piece button code. I'm just going to check the original code. So I just set an offset. Okay. So set the var offset integer, because it's just a whole number without any decimals. And let's originally set it, let's set it to 10 pixels to start off with. Okay, hit save. And now we have to add some code that will allow us to, in our drop code, before we were just checking if the window x exactly matched the end x variable and the window y exactly matched the y end variable, then it was a correct match. Now it's a little more complicated. We have to do a little more of an equation here, or a couple of more conditions to be more specific and lay out exactly how to do this behavior. So I'm going to go ahead and reference the original code here. Let's see. I'm going to go ahead and just copy this whole if-else statement, and then we'll step through it a little bit. So we're going to replace this one. We originally were checking if it was in the correct spot, and then anything else would send it back to its original spot. Okay, now we're actually doing the opposite in a sense. That I'll read through this and explain this, this long conditional line here in a moment. But if the condition is met, this time we're switching this. If the condition is met, then the window goes to the correct start spot, or back to the original spot, rather than the last time we were checking to see if the conditional was met and it stayed where it was, sent back to the original position else. In this case, if this condition is met, we want this to go back to the original. Otherwise, then it sticks in its correct end spot, and then you can see we just added a function call for check game, which I'll come to afterwards. So what we are in effect doing is using that offset variable, and we're using these 4 different conditionals. If this or this or this or this, if it's any of these things, then it's not correct. Goes back to the start position. So really what we're doing is we're checking both the X and the Y in 2 different ways. First, we're checking the window X to see if it's less than what the window X should be minus our offset variable. So if it's greater than that, or if the window X is greater than the window X end plus the offset. So if it's in between these, it's actually correct. If it's less than what the end position should be minus the offset, or if it's greater than what the end position should be plus the offset, then it's incorrect. But anything inside of that actually makes it correct, and the condition won't be true and we'll go to else. So we do the exact same thing with the Y. Is we check to see if the Y position is less than the end Y variable minus our offset value, or the window Y position is greater than the window end Y position plus the offset variable. So really what we're doing is we have these 4 different conditionals. Each of the 2 coordinates are checked on either side of the offset. And if all 4 of these things are true, or if any of them set to be true, I'm sorry, not if all 4, but if any one of these conditions are met, then the window snaps back to its original position. But if all 4 of them are not met, which means all of these are basically explaining what the bounds of what's a not correct drop is. But if all of them are not met, that means that the piece was dropped within the offset, within where it was supposed to be, and then instead of just letting it go in case it was a little off because of the offset value, it will automatically snap to where it's supposed to be, and then it will check to see if the game is finished, which I'll talk about in a moment. So let's go ahead and test this. Whoops, it's giving me an error because I have not defined my check game function yet, so I'm just going to comment that out momentarily, test it again. And now let's test this. So we have our window. If we drag it somewhere completely wrong, it still snaps back to where it originated. But now if we drag it back here, and because the offset is currently 10 pixels, I can probably be a little bit off, and if I let it go right here, there we go. Now it snaps back into place. Very nice. So I can still drag it away if it's anywhere near. See, this isn't quite good enough, but 10 pixels is quite a bit that I can have it off, and it'll still, well, that was just more than 10 pixels. But in any one of these directions, that makes it a lot easier for kids or anyone else for that matter to be able to drag it into the correct spot. So the next step is to basically just repeat this exact method in each of the different cases. So what we would do is first off undo the comment on the check game function, and we would just copy this if-else statement and paste it into each case. And once you paste it into each case, then we would just again do the find and replace, find the window, and this one will be much more useful. So if we go down here, Command F, instead of window, we want ladder. Oops, I have to hit find next until we get down to it. But there's several within this, so once we get down to this correct spot, so this is the original window one. Now here's our copy, and the only thing that we want changed is the name of that puzzle piece. So if we want all these from window to ladder, we'll start hitting replace, and we'll replace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different places we wanted to switch that. So again, using the find and replace is much faster than just manually even copying and pasting that in all those little spots. So instead of doing the find and replace and going through that with each of these, you get the idea. So I'm just going to go ahead and copy this from the completed code. I'm going to stop this I'm going to copy this entire stop dragging function, and we'll replace our current function with it. Alright, now we can take a quick look, and as you can see, it's basically the same thing for each one. Each one just has its specific puzzle piece name, and the equation is the exact same. None of these less thans or minuses or pluses or greater thans or ors changed at all. It's the exact same equation for each one. We just use the different puzzle name, which will use our different variable names that we set up for each puzzle piece. And at the end, each one is checking the game, and that's because we don't know what order. It's not going to go first window, then ladder every single time. We don't know what order the user is going to put these into place. So each time one gets placed in the correct position, which in each case is under the else clause here, each time it's snapped into the correct position, we have to check the game to see if every piece has been correct except for this last one. We have to see whenever the last piece is slipped into the correct position, that's when we have to trigger the end of the game. But we don't know which piece that will fall on, since the user can do it in any order, so that's why we have this check game function listed at the inside of each case where the correct part of the statement when a puzzle piece is placed correctly. So before we test this, so we don't get errors, we want to go ahead and set up our function, check game. It's not taking any parameters, it's not going to return anything. And we'll set that up. Reminds me I didn't set the return type of void, which just means the function doesn't return anything up here. Keep things nice and consistent. So now I'm just going to hit save before we even test it, because there was a lot of copying and pasting and we're dangerously close to being done here. I have a large chunk of code now. I'm going to test it out. And now after we made it work for the single window, now we should be able to snap each individual piece into place. Just make sure it's still going to the wrong place, or going back to its original if it's dropped in the wrong place. Very good. Now, before we do the final check game function, I'd like to set this offset. Now we can play with this. You know, you could put it up to 50 if you really want to see the effect, and see that even if you're 50 pixels off of the ladder, that was a little more, it's still going to snap into place. Now I think that's a little much. I think 10 was a little much. But again, it's really nice when doing game development to put as many of these game functions, game playability functions, usability functions into variables, so that you can adjust them and change the gameplay based on these variables. It helps you increase difficulty and levels, and let alone just tweak your game so it's more playable. So found a really good offset after playing with it quite a bit to be about 4 pixels. So let's save that, test it one more time, and now I can't be way off, but I don't have to be perfectly exactly on. See, there's still a little bit of white around, and that makes it okay. But there's not too much. If I have a little too much like that, maybe I didn't drop it right in the right place, that's not quite enough. But as you can see, if I want to do it quickly, I had a real hard time doing the window the first time because of the offset, but now it's much easier, but not too easy, so you have to at least have to be somewhat precise. So I found that to be a good value. So we have the main portion of our game working now. We named our movie clips on the stage. We gave them button events that click and drag them around the screen. Then we set up variables for where they started and where the correct place for them to end up was. We set up a switch statement to decide which object that we were dropping, and then on the drop, the most complicated part was coming up with our 4 condition case statement here to check and see if it's dropped in the right place or not, based on that offset value, which, as you can see, makes the game much more playable. It would be, frustrating at best if it didn't have that offset to try and put things in the right place, and children wouldn't even give it a second chance. So now the final part is to go ahead and finish off the game, check the game. So basically it's going to be a single if statement to see if every single piece is in its final position. So rather than typing all that out, I'm just going to go ahead and grab it here from the finished piece. Let's see, I think I had another drag and drop the pieces, checking for the correct location. Yes, let's go ahead and add that up here in our comments. So first we had set up the variables and buttons for the puzzle pieces, which we do. And now we want to, this part will, oops, drag and drop the pieces, checking for the correct location. Let's see, is that how I worded it? Yes. I like to keep things match, succinct, and have good continuity. It's very important when programming things. And now we'll just add our final function here, which includes the final comment, check to see if the game is complete. So we just created this simple function, check game. Again, we place at the end of every piece dropping into the correct position. And then we just have this simple one-line if statement that if all of this stuff is true, just go to and play game over, which is just a frame label on the timeline that plays a sound and an animation. What's inside the if statement here is just taking each of the 6 pieces and checking to see if both the X and the Y are sitting exactly on their end spot. Now, we don't need to worry about using the offset here because luckily, or else this would be much more complicated, when it's dropped in the correct place within the offset, we automatically snap the piece to its exact end spot. So when we're checking if the game is finished, we don't need to check if the piece was dropped anywhere within the offset, because if it was, it should have snapped to the exact position we wanted it to, which also is visually helpful to make the puzzle look more completed as well, instead of seeing little white borders around the pieces. So with the window, see that its X position is equal to the window end X and its Y position. Now up here we were using OR commands, which meant if any 4 of these was true, it was not in the right spot, and if all of them were not true, it would send out here. Now in this case, since we're using AND, every single one of these has to be true in order for the game to be over. So we want to see if the Windows X is equal to its final X position, that we set up in a variable if the window's y is equal to its final y position, and it's pretty much those two copied for each of the other 6 pieces. So each of the other 6 pieces just says if its x is equal to the end x and if its y is equal to the end y. And if all of those are true, and again, we don't know which order these are going to go in, but if all of these are true, that means that the final puzzle piece was placed in the correct spot, and now you can go ahead and go to and play game over. So we're going to save the file, test it out, and let's go ahead and play the game here. So you can fill this in. Just do a couple tests and make sure they're still snapping back to position if they're not dropped correctly. Yep, that seems to be the case. Alright, and there we go. We did a great job, and that's our simple animated message and cheering sound that comes up when it finishes that. So there we have it. There's our simple puzzle drag and drop game for kids. Like I said, this functions quite nicely when we published it for iPad because those mouse commands also work with the touch commands by default. Hopefully this will get you started on making your own game of this type. From here, it would be useful to perhaps keep track also somewhere in each of these case statements when something is dropped. Maybe when it's dropped not in the correct place, maybe instead of just sending the piece back to the edge, maybe you want to give the user some kind of prompt that they made an incorrect drag, or maybe you just want to keep track behind the scenes of how many tries it took to get it correct, so you could, track a little more of the performance. There's a lot of things you can do from here. But anyway, hopefully that will help you get started.